Hello everyone, so welcome back to the good stuff that we've been doing. Today in this video we are going to try to expand the function y equals to sine inverse of x all squared, and by expansion we want to express the function y in the form a sub 0 plus a sub 1x plus a sub 2x squared plus all to a sub n x to the n, and the series goes to infinity. Now, one way this is done is usually by Taylor's theorem, which says that we can find the coefficient a sub o, a sub 1 as follows: that a sub o is what you get from f prime differentiating x at 0, and a sub 1 is what you get by just a sub o is just f prime of f of 0. So a sub o is just f of 0, and a sub 1 is what you get by differentiating f at 0, and a sub 2 is what you get by plugging in 1 over 2 factorial of f prime prime at 0. Likewise, a sub 3 is what you get by 1 over 3 factorial f prime 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 at 0. But the problem with using Taylor's formula to solve this problem is that this function is very complicated, especially derivative. So if you try to even take the second derivative, you find a very complicated expression. So it makes it impractical to continue differentiating it. And the worst case is that most of the derivatives you get, you can't be able to find the relationship between the next term. Like in terms of y equals to cosine of x, we know that usually the coefficients are 1, -1, 1, -1. But this time around, you can't be able to spot a pattern by taking derivative here. So it makes Taylor's theorem impractical for solving this problem. Now, the way to go around it is what we call formation of differential equation. So we form formation of differential equation. So we form a differential equation that this function y equals to sine inverse of x satisfies. And once that differential equation is formed, we are able to pick out the coefficient from that differential equation. I will show you how just in a moment. Now, from this y equals to sine inverse of x all squared, the first derivative dy dx would be 2 sine inverse of x, right? They have to take derivative of sine inverse of x, which is 1 over square root of 1 minus x squared. Now when this is done, we have to square both sides. So when we square, or let's say square both sides below here, we'll have dy dx all squared is 4 sine inverse of x all squared multiplied by 1 minus x squared. Now obviously we can multiply both sides by 1 minus x squared. We are going to have 1 minus x squared dy dx all squared. So I'll put it in brackets, dy dx all squared then equals to 4y. The reason I say 4y is because y already is sine inverse of x all squared. So what can we do with this? Obviously we can take derivative again, and when that is done, we have derivative of negative of 1 minus x squared is negative 2x. So we have negative 2x multiplied by dy dx all squared. Now the derivative of dy dx is 2 dy dx times d square y dx squared. So that will be plus 1 minus x squared d square y over dx squared. Then we'll have dy dx. So this will be equals to, and okay, that will be a 2. I forgot to write, so let's say 2. So this will be equals to 4 dy dx. 4 dy dx. Now notice here that dy dx can be found in each of these terms here. So we can divide both sides by dy dx, and we get negative 2x dy dx. Then we'll have that is 2 dy dx. So we can just cancel that, this 2. So that is negative x dy dx. Then we'll have plus 1 minus x squared d squared y over dx squared. Then we'll have equals to 2, that is all, just 2. So let me write it over to this point. So we'll have 1 minus x squared d squared y over dx squared minus x dy dx. Then we'll have minus 2 being equals to 0. Let me confirm. Alright, so negative x dy dx plus 1 minus x squared d squared y over dx squared. Then we'll have subtraction from 2 being equals to 0. Now the next step for this expression is to Since the differential equation has formed, the next thing you do is to set y to be a sub 0 plus a sub 1x plus a sub 2x squared plus a sub 3x cubed, then plus up until a sub n x to the n plus a sub n plus 1 x to the n plus 1 plus a sub n plus 2 x to the n plus 2 up until infinity. So this is your value of your expression y, and our goal here is to find the coefficient, but we have, as we have pointed out, Taylor's formula is not practical for finding the coefficient. But luckily, the way we are going to use the differential equation to find the coefficient is that we are going to have to take the first derivative and the second derivative and plug it into this equation. Once we take the first derivative and second derivative and everything gets plugged into the original equation, what do we have? We have a polynomial expression that is equal to 0. So this basically means that all the coefficients of that polynomial should be 0. So let's take derivative and see. So derivative is dy dx, which is equals to a sub 1 plus 2 a sub 2x plus 3 a sub 3x squared, right? And then we are approaching up until n a sub n x to the n minus 1 plus this is n plus 1 a sub n plus 1 x to the n plus n plus 2 a sub n plus 2 x to the n plus 1. Yeah, so the squared y over dx squared should be now a sub 2. Okay, that would be 2a sub 2, 2a sub 2 plus 3 times 2a sub 3 x plus, then we have n multiplied by n minus 1 a sub n x to the n minus 2 plus we have n plus 1 n plus 1 a sub n plus 1, the x to the n minus 1, then we have plus n plus 2 n plus 1, then we have multiplying a sub n plus 2 x to the n, that is s to the n only, then everything goes to infinity as well. Now, just like I have pointed out, if we plug in all this expression in this equation, we have something like, let's say ax squared plus bx to the third plus cx something, like we have a polynomial expression and we are told that this whole thing equals 0. That means each of the coefficients of x, so the coefficient of x to the n of x to the n should be equals to 0 on the left hand part. That is what it means. So if we plug all these expressions for dy dx, for the square y over dx squared, everything, if you plug it into this differential equation, we're going to get a polynomial of this form, for which in this case the coefficient of x to the n should be equal to 0, and that is how we're going to solve this problem. So let's plug it in. Let me make a space for us. So, but we're not going to plug in directly because we can always pick out the coefficient. Now we are going to ask ourselves, what is the coefficient of x to the n on this part alone? Oops, let me get it. So what is the coefficient of x to the n on this part alone? Well, the coefficient of x to the n is equals to the coefficient of x to the n when we multiply the square y over dx squared by 1, and the coefficient of x to the n minus 2 when we multiply the square y over dx squared over multiplied by x squared. Okay, let's say, what is the coefficient of x to the n in this square of y over dx squared? Well, let's pick it out. This is the coefficient of x to the n, and we write it out. That is n plus 2 n plus 1 a sub n plus 2. So this is the coefficient of x to the n. Then what is the coefficient of x to the n minus 2? Because we are multiplying this by negative x squared. So the negative x squared, we are now interested in the coefficient of x to the n minus 2 in this expression, and no longer the coefficient of x to the n. So what is the coefficient of x to the n minus 2? That would be this expression. So that would be minus n minus 1 a sub n. This is the coefficient of x to the n minus 2. Now what is the coefficient of x to the n minus 1 here? Because we're multiplying this by x, so we need the coefficient of x to the n minus 1 here. That would be dy dx. What is the coefficient of x to the n minus 1? That would be n a sub n. So that would be minus n a sub n, and everything will be equal to 0. So that is the coefficient of x to the n on the left hand part. We don't care about the 2 because it just gets mixed up with one of the constants, and everything definitely will equal to 0. Like, we need the coefficient of x to the n specifically. So that means that n plus 2 n plus 1 a sub n plus 2 is equals to a sub n. Then we'll have to write n minus 1 plus n. So that will be equals, no, this is a sub n. That will equals a sub n squared minus n plus n. So that will be n squared a sub n. So let's flip over to the next board. So this basically means that n plus 2, okay, n plus 2, n plus 1 a sub, n plus 1 a sub n plus 2 is equals to n squared a sub n. So this basically means that a sub n plus 2 is equals to n squared over n plus 1 n plus 2 a sub n. Now what have you achieved? What we have achieved is that if y is a sub o plus a sub 1x plus a sub 2x squared plus up until infinity, then if y is equals to sine inverse of x, so this coefficient a sub o, a sub n, they satisfy the recurrence relation. This satisfies this relation. So this formula will allow us to find a sub 2 if we know a sub 0, and it allows us to find, notice that this formula n is bigger than or equal to 1. That is for sure. N is bigger than or equal to 1. So we can't even plug n equals to 0 in this formula, but we can plug in n equals to 1. So if we plug in n equals to 1, you get that a sub 3 for n equals to 1, a sub 3 is equals to 1 over 1 plus 1, 2 times 3, that is 2 times 3 a sub 1. So that means that a sub 3 depends on a sub 1, and if you plug in n equals to 3 as well, a sub 5 will depend on a sub 1. So a sub 5 will depend on a sub 1. That will be 3 squared all over 3 plus 1, that is 4 times 5 a sub 3. So a sub 5 depends on a sub 3. Now we need to only know a sub 1 to find the rest of the a sub, the odd coefficient. And what about a sub 2? A sub 2 cannot be found here. Likewise a sub 1, because this formula is only true for n bigger than or equal to 1, but we can find a sub 4, and a sub 4 depends on a sub 2 by plugging n equals to 2 here. But luckily for us, we can the Taylor's theorem that we rejected, we can as well use it to find the coefficient of a sub o, a sub 1, a sub 2. It can be used to find this coefficient. Let's try our luck on it. For a sub o, we only need to get f of 0. So that would be sine inverse of x evaluated at 0. So I'll put 0 here. All squared, that would be 0 squared, that would be 0. So a sub 0 is 0. What about a sub 1? A sub 1 is f prime or as evaluated at 0. F prime evaluated at 0 is 2 sine inverse of x, and we have to divide by square root of 1 minus x squared. So if we evaluate this at 0, that would be 2 multiplied by 0 over 1. So that would be 0. So a sub 1 is 0. And shockingly for us, that means that a sub 1 is a sub 3 is a sub 5 is a sub 2n plus 1. All the odd coefficients will be 0 because of, as we have said, a sub 3 depends on a sub 1. So if a sub 1 is 0, automatically a sub 3 is 0, and likewise a sub 5 is 0. So all the odd coefficients are 0. What about the even coefficient? But luckily for us, a sub 2 is half of f prime or evaluated at 0. But the problem is that this f prime is a little bit complicated. But I'll show you a trick you can use. This is equals to twice of now you take the derivative of, just assume this is 2 sine inverse of x multiplied by 1 over square root of 1 minus x squared, and we use the product rule. So first of all, take derivative of this expression and we'll get 2 sine inverse of x. Derivative of sine inverse of x is 1 over the square root of 1 minus x squared, and notice that we are going to multiply by 1 over square root of 1 minus x squared. So instead of writing the square root, we just write a 1 minus x squared term, just 1 minus x squared term, and then we add it with, now we have to multiply 2 sine inverse of x now by taking derivative of this expression, but we don't care. So I'll just write a for this expression, because even if this expression gets whatever derivative may be, everything here should be 0, because if you plug in x equals to 0, sine inverse of x goes to 0. So notice that, okay, this half, this means that this is 1 over 2 dividing this, so this goes to 0 and 2 over 2 is 1. So that means a sub 2 should be equals to half of f prime prime evaluated at 0, that will be 1. So a sub 2 is 1. So let's pick our work together. So here a sub o equals to 0, a sub 1 equals to 0. Okay, let me say a sub 1 equals to a sub 3 equals to a sub 5, or equals to 0. Now a sub 2n, okay, a sub n plus 2 is n squared over, that will be n squared, not n cubed, n squared over n plus 1, n plus 2, a sub n. So this case here, n is bigger than or equals to 1, and we know that a sub 2 is equals to 1. So what about a sub 4? A sub 4 is what we get when we plug n equals to 2. That will be 2 squared all divided by 2 plus 1, that is 3, multiplied by 2 plus 2, that is 4. A sub 2, that is 1. What about a sub 6? That will be what we get when we plug in n equals to 4. That will be 4 squared all divided by 5 multiplied by 6 times a sub 4. That will be 2 squared times 4 squared all divided by 3 times 4 times 5 times 6. That will be a sub 6. What about a sub 8? A sub 8 is what we get when we plug in n equals to 6. That will be 6 squared all divided by 7 times 8 multiplied by a sub 6, which is 2 squared times 4 squared times 6 squared all divided by what? 3 times 4 times 5 times 6 times 7 times 8. So this y equals to a sub o plus a sub 1x plus a sub 2x squared plus up until a sub nx to the n to infinity, and y is sine inverse of x all squared. The expansion, let me put it in red. The expansion y is given by a sub o is already 0, but a sub 1 is 0, right? So a sub 2, this will be 1x squared. A sub 2 is 1, so this is x squared plus what is a sub 4? A sub 3 is 0, so a sub 4 will be 2 squared over 3 squared times 4 squared x to the 4th power plus what is a sub 6? That is 2 squared times 4 squared all divided by 3 times, okay, no, this is not 3 squared and 4 squared, this is just 3 times 4, my bad. This is 3 times 4 times 5 times 6, right? So that will be x to the 6th power plus this will be 2 squared, a sub 8, this will be 2 squared times 4 squared times 6 squared all divided by 3 times 4 times 5 times 6 times 7 times 8, right? X to the 8th power. Then we add it up until infinity, where, and we, from this formula now, we know that the coefficient, we have seen the pattern in the coefficient. So notice that for you to even get this value, you need to take the derivative of the expression 4 times. You need to take the 4th derivative for you to know what is 2 squared and 3 times 4. And it is unlikely that you will get to this point, because at some point you have to cancel 2 squared and 4, which means that you're only getting 1/3. So you're not going to even get a clear, you're not going to really understand what the end derivative will be. But luckily for us, this method have solved the problem for us completely, and we're able to expand this expression y equals to sine inverse of s all squared in series expansion. So thank you for watching, and if you want to keep up with the great videos we share on this platform, please like and follow. Thank you very much.